All right, so this is an extension of the previous question where we've already solved this equation, but since it's cubic, we know that we're supposed to be finding three solutions. But whenever you take the cube root, you only get one real one. Where are the other two? The other two are imaginary. So the process was, like I added the negative 5 over there, got negative 16 divided by 2, so x plus 5 is equal to negative 8. Whoops, that's to the third power. So it's at this point right here that we would be taking the cube root. So x plus 5 is equal to all of the cube roots of negative 8. So the real one was just negative 2, and that's what we used on the last problem in order to solve the problem. But it's at this point that I'm going to use the formula, and since that 8 is negative, I'm going to use this one to find the other two. But it's at this stage. So in other words, once I find the other two cube roots of negative 8, then I'm going to set it equal to x plus 5 to find the actual other two solutions for this cubic equation. Okay, so the first part of this formula has the nth root. For us, that's cube. The nth root of the absolute value of r. So this was a key mistake that some people made, and that is it's the absolute value of the number that's in there. I don't want the cube root of negative 8. I actually want the cube root of 8, which is just 2. Okay, and that's the principal one, and that's the one that we use here. So we go 2 on the outside of this, and then some brackets. Now I'm going to simplify what's inside the brackets here with the sine and the cosine, the imaginary part here. So I'll have cosine of, and remember our n value is 3 for each of these. So I can simplify what's in the parentheses, the angle measurement, by 3, just dividing everything by 3. So 180 divided by 3 is 60, plus 360 divided by 3 is 120k. So there's the real part of it, plus I times the sine of that same angle. 60 plus 120k. Okay, so now we have to evaluate this for k, and it says for 0, 1, 2, all the way up to 1 less than the root. So what we're going to do, 1 less than the root, of course, is 3 minus 1, which is 2. So we're just going to go from 0 to 2. We're going to plug in k equals 0, 1, and 2. Now we may not have to do every single one of these, because if I find one of the complex ones, all I have to do is find the other conjugate of it, and then I'm finished. So let's start with 0. So if I plug 0 in here, k equals 0, this is what I'm going to get. I'm going to have 2 times the cosine of, that looks ugly, inside this angle measurement, whenever I plug in 0 for k, that'll disappear, and I just have 60, plus I times the sine of 60. Okay, and so I can use the unit circle in order to compute the cosine of the sine. I don't have to use a calculator. Some of you probably did. That's totally fine. But I'm going to use my unit circle here. And I'm talking about a 60-degree angle. So a 60-degree angle has a 30, 60, 90 triangle in it. The hypotenuse is 1. The short leg there, which is the x-coordinate, is a half. And then the longer leg, which is going to be the sine, the y-coordinate is the square root of 3 over 2. Okay. So the cosine of a half, or cosine of 60, is just a half. So I'm going to keep simplifying here. 2 times cosine of 60 is 1/2. Plus I times the sine of 60, which is the y-coordinate, which is the square root of 3 over 2. Now I just have to distribute this 2 through that, and I'm going to have 1 plus I square root of 3. And believe it or not, I don't have to do the rest of the formula, because remember, when we were studying polynomials, if 1 plus I square root of 3 is one solution, then 1 minus I square root of 3 is the other solution. They have to come in conjugates, conjugate pairs. Okay, so I'm almost finished here. Here are the two other, these are the two imaginary roots of the cube root of negative 8. Now I'm just going to set that equal to x plus 5 to find the other two solutions. So I have x plus 5 is equal to 1 plus or minus I square root 3, and then subtract this 5 guy over here. X is equal to negative 4 plus or minus I square root of 3. And there we have it. Those are the other two imaginary solutions for that original equation. Of course, you may have used the calculator for the square root of 3, and I think that's like 1.7, something like that. But there's the exact answer.